Okay, so just a tiny little review of trig, what I asked you to know from yesterday. Number one here, if you're going to find cosine of theta, cosine, I go to ka for cosine, and I go, oh, so you want adjacent over hypotenuse. That's the angle. Which one's the adjacent side? That one. And which one is the hypotenuse side? That one. Okay, so you should have said 4/5. Raise your hand if the person you are grading did that one right. Okay, good. Then, for number two, it's the what triangle. I personally like to say them in this order. If it's these two first, because those are the same. It should have said 1, 1, and root 2. And then on this other one, the smallest angle goes with the smallest side, and I'd always start with that one, 1. And then I jump to the hypotenuse because it's always double what that one is, 2. And then the third side, root 3. 1, 2, and root 3. I want you to count these as 1 point for this, 1 point for that, and 1 point for that answer. So they have a score out of 3. How many of you just graded a 3 out of 3? How many just graded a 2 out of 3? A 1 out of 3. All right, thank you. All right, back to your spots. Pause for a second while we do that. Next thing with the switch over in teachers, I understand that some people have different rules when it comes to phones. Mine is pretty simple. You don't have it out until work time. So don't have it sitting on your desk. You can't just say, well, I wasn't using it, or I was using it for a calculator. I don't want to hear any of those excuses. Just don't have your phone out until work time. All right, so do you feel comfortable with this, or is there any part of this that you need me to review with you? Let me know if you're stuck now. Tell me now. Okay, why would you need to know these? For an example, let's say that you are faced later with this triangle and you don't know those ratios, then it'd be really hard for you to answer a question like this. This side here is 4. How long is that side? It's not an easy question unless you know those ratios. If you know those ratios, it's easy. You got those ratios memorized. I like to then just make my helper triangle next to it and go, well, I know it's supposed to be 1, 1, root 2. So then you can kind of look at this and go, oh, yeah, so these are the same. So that means this is 4. And then if I scale this up to be 4 times bigger, then it'd be exactly right. And so that means this side here must be 4 root 2. Okay, that's why we need to know those for an example. All right. So one of the main things I need to teach you on this new lesson is about how if you have one side and one angle, that's all you really need. If it's a right triangle, just to clarify, so technically you actually have two angles because one, it's a right triangle, so you know one of them is 90. And if I know this side is, let's say, 7, and I know this angle is, let's not make it a 30-60 just so you see it works for other things too. Let's say that's a 50-degree angle right there. All I need is that, and I can find all the other angles and all the other sides using trig. All right, now this one is not going to come out nice because I intentionally didn't make it a 30-60-90. But this you can do in your head. You don't need a calculator for that. What angle is sitting over in that corner then? Well, what do they have to add up to? These three have to add up to what? 180. And therefore, we already got 90 plus 50 makes 140. So how much is left? 40. Another way to think of it is, here's 90, and these two together need to be 90. And therefore, this must be 40. Do you get how you can always get the third angle? That's easy. Okay. Then how do you get those other sides? Who in here right now, with the help of a calculator, could figure out how long that side is? Maybe? All right. That's what I'm teaching you today. Okay, I'm going to pause for a second while I pull up the right file on off of Schoology. So here's what a Schoology page looks like, and you would be finding this one right here. Trig ratios day 1 and 2, January 23rd and 24th. And I'm going to open up that one right there. You're going to open up this one. I'll pause while they open. Okay, so this is the right file. Does yours look the same? Your first slide look like that? All right, good. Would you please put it on the first slide and then turn your iPad my way. I want to see who I'm still waiting for that has not found this file yet. Put it on the first slide. It should be orange, and then I'll know who to come and check on in a minute. All right. Looks like I'm waiting for one person. All right, maybe two. Okay, so let's get to, this was special triangles that we already covered from yesterday. Not doing that one. This one is unusual because it's not a right, oh wait, it must be a right triangle the way they've got it set up. It's just the right triangle's in a weird spot. But I've been telling you that we can find, as long as we have one side and one angle, we can find any, all the rest of, in fact, the answers. So I want to get to that kind of question here. Before I get there, do you get that this is all one angle? Looks weird. Sine of 1346 dash? What the heck is that? That's sine of 13 degrees and 46 minutes, which is like 13.2 or whatever the decimal is, degrees. If you see this, don't stress. There's a way to put that in your calculator that I'll show you later. It's not the kind of thing we focus on a lot. It's just we want you to know that the angles can have degrees and minutes. So if it's 13 degrees and 46, what does that mean? 13 degrees, 46 minutes. It means it's 13 point something degrees. And your calculator has a converter that they can use. Otherwise, you can say 46 minutes is 46 30th. Sorry, there's not 30 minutes in an hour. If this is minutes, it's like minutes out of an hour. It's 46 60ths. If you want the decimal, you can just do it that way if you don't know how to do it on the calculator conversion. All right. All right, that's really quick on that because I know how not important it is. Okay, now this uses those classic right triangles that you already have memorized. I hope with the 3069 and the 4545 being memorized that you can do this. I don't recommend that you put the originals in here. I know it's 1 root 2, but I don't recommend that you put it that way. I recommend that you take and off to the side in the same orientation. Do you get I could have drawn this triangle a lot of different ways? It could have been like these two sides in that way. Put it in the same way that they drew the original, and I call this my helper triangle, 1 root 2. And then I can look and compare this one and that one, and that'll help me to figure out what goes here. I'd call it X. What goes here, I'd call it Y. Or you could call it A, B, and C. You could pick any letters you want for these. But no matter how you slice it, can you solve that kind yet? I'd like you to try these two as practice. That means actually do them right now. And you're going to be comparing to the kid next to you and see if you get the same answers. Okay, I know that first one probably went pretty fast. You were just going, okay, so this has to be the same as this one. So these have to be 2 and 2. And then this just must be, well, it's all 2 times bigger, right? 2 root 2. How many of you had that part already? Okay, good. Then, how about the other part? Definitely more complicated. But if you do it the way I suggested, and you make your little helper triangle off to the side, your 30, 60, 90 helper triangle. This is 1, 2, and the square root of 3. I will show you how to make this go easy. Please, make the little helper triangle. This is not something, oh, I can just do that in my head. Doubt it. Okay. I'm going to call this A and this C. You don't have to. You could have called it Q and M. Doesn't matter what you call them. I'm going to call them A and C. Why? Because typically on triangles, we call their sides A, B, and C, or their angles A, B, and C. And C is usually the hypotenuse. But I could have used any letters here. Now, let's see if you can follow me here. 22 is to root 3. 22 is to root 3 as C is to 2. As C is to 2. Would you be able to solve that? That would tell me what C is. if you understood that, would you please make me another one of those that does it for A? A is to this as that is to that. Make me one of these kind of equations that involves A, not C. I'll pause for a second while you give that a try. Okay, here's what I hope you did. If it involves A, do you get that A goes with 1? So I would have said A goes with 1 like 22 goes with root 3. And look at that, it's already solved for A. A equals 22 over root 3. There's more than one way to do that. If you wrote it differently, but it would have solved for A and still got to 22 over root 3, you're okay. All right, let's do one more like that on a 30, 60, 90. Say this is the 30, this is the 60, and this is the 90. And this side, you know, if I was going to label them, I'd say 1, 2, root 3. That's the ratios, but I'm going to call this 17. Would you please figure out what side Q is? I would make the helper triangle next to it, a little helper triangle over here or over here in the same orientation where you know those ratios. And pause while you give that a try. Okay, here's how I do the helper triangle. This is the 1, and this is also, yes, I'm secretly making you practice that helper triangle thing over and over again. 2 root 3 triangle. Okay, do you have that much right? Then, what goes with what? What goes with what? I would start here and go, oh, obviously these two go together. Now you can either go 2 goes with 17 or 17 goes with 2. Doesn't matter. I'm going to say 17 goes with 2. Like, and then I'm going to jump over to this one and say Q goes with root 3. And then I'm close to done. Is Q solved yet? Nope. So I just have to get rid of the denominator, times both sides by root 3. And now Q's alone, so it's 17 root 3 over 2. How many of you had that as your answer or something that would equal the same thing? Okay, good. All right, now let's get to, this is practice 1, practice 2, practice 3. All right, these are much more intense. So I don't feel like we're ready for this one yet. I'm going to do one more slide to kind of lead up to that one. All right, so everybody get a blank page or go off to the side somewhere. We can do one more practice problem before we hit those complicated ones. All right, one factoid you need to know about triangles is there's another classic triangle. It's not the 30, 60, 90, and it's not the 45, 45, 90. It's this one. You know what it is? 60, 60, 60. And what's special about it? It's called the special name, equilateral, and that means its laterals are equal. What does lateral mean? You know what your lats are? You know, like from pull downs, they're those on the side of you, right? They're the sides. So equilateral means equal sides, so the sides are all equal on a 60, 60, 60. All right, so I just need to bring that up because that's kind of like the third one, but it's just so easy. It's the 1, 1, 1 triangle is the way you could say it, right? Do they have to be ones? Of course not. Just like the ratios and the other ones don't always have to be 1, 2, and sorry, the ratios have to always be the same, but the numbers can be different. So this could be, of course, 8, 8, and 8, for instance. And then they would always be 60, 60, and 60. All right, so that's important to know. It's just like the last little piece. So what if this was a 50-degree angle so that, again, it wasn't going to work out nice? And let's say that this side was, that's the easy side, because if I give you that side, okay, I'll do that side. That's fine. I'll start with an easy one. Let's say this is going to be 7. Can you please figure out, this should be the no-brainer part. We already did it this hour. What's that angle? But more importantly, what's this side? And I'm going to call it x. Figure out how long x is. Now, this one's going to require a calculator. So if you haven't already got one out, grab a graphing calculator, because you're going to need to be able to do like sine, cosine, or tangent of 50 to answer this question. Because you don't have a classic 50, 40, 90 triangle to go back to. You wouldn't want to memorize every possible combination of triangle anyway. So hint, if your memory banks are like weak on this, You're going to either do sine, cosine, or tangent of 50 to write a little equation and solve it. I haven't taught you this yet. I'm seeing if you remember. Okay, so it's okay if you don't know how to do this right now. When you walk out today, you need to know. All right, so see if you can write this. I'm not going to do this right intentionally. Something like this. That is not the right equation, but something like that is what you're looking for. Okay? See if you can figure that out. I'm going to pause for a second. Okay, so let's see if you set it up right. First of all, it wasn't sine. What was it? How do you know it's tangent? Well, this is the angle in question, right? The 50. So then it must be what's across from the 50 and what's next to the 50, and which one does that? Well, first of all, I'd figure out what those are. This one's adjacent to the 50, and this one's opposite from the 50, and then you go back to SOHCAHTOA. So often it comes down to that. Which one of those has opposite and adjacent in it? Only that one. Therefore, it must be tangent. How many of you are using tangent of 50? How many of you got that far? Awesome. That's at least half the class knew it was tangent. Then, if I know it's tangent, tangent of 50 equals what? This is a big mistake. People go, tangent of 50. So I type it in my calculator and I get the answer is like 0.73 or whatever it is. I don't know what tangent of 50 is. Why don't you, somebody type in tangent of 50. What is it? Yes. Okay, now some people are in radians and some people are in degrees. That's why two kids can type in the same exact thing and get a different answer. What did you get? 1.19. What did you get? Negative 0.271. Anybody get a different answer than that? Okay. So exactly, one's radians, one's degrees. Go back and look at your mode right now. You may want to watch the video to catch the rest. If you're in radian mode, get it out of radian mode. It's actually the default for the calculator. The default is radian mode. So you got to make sure you're in degree mode. Now I know, by the time you're done with this far into next year, you're going to be back into radian mode, but by then you'll know what a radian is. Can anybody in here right now tell me what a radian is? Therefore, do you want to be in radian mode? Probably not. Okay, so get into degree mode. So under mode, get into degree mode, and now tell me, what's tangent of 50? There's one of those two. 1 point what? 1.192? Let's round it to 1.2. Is that okay? All right. Let's call it about 1.2. But here's the mistake. Don't do that. Because you want to set up an equation, and you'll put in the 1.2 in a minute. Tangent of 50 is equal to TOA, opposite over adjacent. What is the opposite side? It's x. What is the adjacent? It's 7. Do you get this? This is the classic setup. This is the most important setup. We'll practice it until you got it, but that's the setup. Now we replace the tangent of 50, which you figured out and is important. We'll put it here. 1.2 is x over 7. And again, if you can't solve that now, see what I'm saying? It's just multiply both sides by something and you're done. That's going to make it super easy. But to be able to do it, you got to be able to figure out how to write this equation. Do you get how I wrote that equation? All right. Now you just multiply both sides by 7, and it's 7 times 1.2 is what x is. All right. Let's see if you can do that again. This time it's 20 and 90, and this side is going to be 5. Would you please figure out how big that side is? Hint, you're writing me something like this. Cosine of 20 degrees is equal to x over 5. It's totally not that, but something like that. And then once you figure out cosine of 20, or whatever that's kind of like that, and it comes out to like 8.6 or whatever, you'll be able to solve for x really easy. Okay, so make me an equation kind of like this. Once I get almost everybody making the equations right, then we can focus more on actual answers. Okay, so see if you got the equation right. Compare it to the kid next to you. It's not cosine. It is something of 20, and it equals some fraction. I'll pause while you compare it to the kid next to you. Okay, so which one was it? Sine, cosine, or tangent? Sine of the 20. Because why? Because of the 20, we have its opposite and hypotenuse. That's the one in SOHCAHTOA that has opposite and hypotenuse. So it must be sine. Sine of 20 is x over 5. Raise your hand if you had it set up right. Cool. Do you get, I don't even really need the calculator to times both sides by 5 and get x equals 5 times sine of 20? You know why that's better than using the calculator? Because it's exact. You get, as soon as you type in sine 20 and get an answer, that's a decimal that's been rounded. The one on the board hasn't been rounded. See how in a way it's better? Because this is exactly what x is. Now, I get, you've got a calculator, you're probably going to use it and get a decimal. I just want you to get that when you, as soon as you do that, that's rounded. It's close, but it's rounded. What was sine of 20? Save me some time. Point something? 0.34, can anybody corroborate? Make sure that's right? Okay, good. Thank you. Then 0.34 times 5 must be about 1.6 or something like that. 1.7-ish. Okay. All right. Are you getting this? Now, congratulations. You're back to where you should have been last year. Now I got to get you to the new stuff. All right. That's the basics of setting up a triangle with trig. I am going to show you this page now. And there's practice 1. I'm going to have you focus on this one right here. Because what did I tell you you needed? One side and one angle. And if you're going to try to figure out x, you look at this and you have an angle, but you don't have a side in that blue triangle I just did? So you got to figure out how you can get a side, because as soon as you have one side and one angle, you can do it. So of course, the next step on these is to give you ones that don't have a side, but they really do. It just takes you a minute to figure it out. I will pause for a second while you try to figure out practice number 1. Okay, suspense is over with. The people that are good problem solvers have already gone. 60, 60, that's got to be 60 because it's a triangle and they have to add up to 180, right? And what do we know about the 60, 60, 60? They're all the same. And therefore, if all the sides are the same, this must be 2. And now we have a side and an angle in that blue triangle. And now we kick into the thing, how do you write that equation? So you go, is it sine, cosine, or tangent of 30? Tangent of 30. Because why? Because we had, if these help you, you can put them in there. TOA. We had opposite over adjacent. And opposite side is 2 over adjacent side is x. And there we go. Am I done yet? Now I'll take a little bit of time to finish the deal. But I'll multiply both sides by x. And then I'll have the x. I don't have a fraction problem anymore there. X times tangent of 30. Well, then I have to divide both sides by tangent of 30. X equals 2 over tangent of 30. How many had the same thing? Good. Okay, question. You can, but you still needed to have the side, though. You had to figure that out first. But then, yes, this is a 30, 60, 90, so you could have done that one with the helper triangle. That would have been totally okay. Answer's still going to come out the same way. And I know you might be like, well, the helper triangle actually would have had numbers here. It's because you can figure out tangent of 30 in your head with the helper triangle. Let me show you that. Tangent of 30, you're like, how could I know that? Because if you look at the 30, 60, 90, you know that's the 1, 2, root 3 triangle, right? So tangent of 30 is TOA, opposite over adjacent. It's 1 over root 3. So I can do tangent of 30 and just say it's 2 over 1 over root 3, which would make it 2 root 3. I know, kind of going fast, because today is a I have to cover a lot of material, and it's a masked day, so it's not going to normally be this crazy. Go over to practice number 2. Everybody look at practice number 2. For practice number 2, what did I say you needed again to be able to do these? One what and one what? One side and one angle. All right. Do I have one side in my right triangle? Yes. Do I have one angle in my right triangle? Yeah. I got a side and I got an angle. Therefore, I should be able to figure out that side, right? Do you get then within this little triangle right here, I will have one side because I'll know what this is and one angle. See what I'm saying? So if your goal is to just find x, you might be looking at this blue triangle and saying, well, I only have one angle. I need a side. That's what this stuff is here for, because in this big green triangle, I do have one side and one angle. All right, need to move on. So we're going to get to the string problem. All right. Judging by our amount of time that we have left, I don't have time to have this all set up in class. I have string and stuff, but it would take a while. All right. So you're just going to have to imagine that this is the ceiling in the classroom, and I want to know how high the ceiling in the classroom is. Let's say I don't know, and I don't know. I don't know right this second how tall that is. It looks to be about 8, not maybe 9 feet. I don't know, maybe 8 feet. What do you guys think? 8 feet, 9 feet? 8.5? Okay. Anyway, let's say I don't know how high it is, but I can figure it out. So let's say that I have 2 pieces of string that I use to go up to the corner of the classroom. So right up there, where kind of up by the clock there, I'd have 2 pieces of string. Can you imagine that I could know how long those pieces of string are? Because I could like stretch them out on a ruler or something and figure out how long the string is. Okay, so let's say I say this piece of string is 10 feet. And do you get that this piece of string would be less? Let's say it's 9 feet. You with me so far? Then I could use that to figure out how big h is. But what would I need to know? What do you need in a right triangle? One side, one angle. I got the sides. I just need the angles. All right. So let's say I knew that this was 60 degrees. And let's say that I knew, no, actually that doesn't make sense. Sorry. In this that drawing, this is the smaller of the 2 angles. So let's say that's a 30-degree angle. And let's say this is a 60-degree angle. Now, some people are better at spatial stuff than others, but do you get I have 2 right triangles here? The blue right triangle, which has one side, one angle. And I've got this black right triangle, which has one side and one angle. Do you get that either one of them would have told me the answer? That would have been too easy. Do you get I could have done that separately? I didn't really need 2 triangles. That's why this says with only measuring angle A, angle B, and x. As in, I don't know how long these strings were in the first place. I don't know the 10, and I don't know the 9. I only know the x. That's what makes it pre-calc, in fact, honors pre-calc level stuff. Because it would have been too easy if it was the other way. All right, so let's say this is 30 and this is 60, and the distance between this was 2 feet. X was 2. How on earth would you do it then? All right. Well, to start with, you see I still have 2 triangles. Essentially, I got the black one here, and I got the blue one. It goes all the way around, the big one. I need to have 2 equations one for the blue triangle, and one for the black triangle. Do you get that I don't even have a side? That's what makes this extra hard. Let's call this side in both of them H. And let's call this unknown distance right here, I shouldn't call it X because we already had an X. I'm going to call it Y. Do you get that now I have a drawing that has two variables? Then, have you ever heard this before? If you have two variables, then you'll need two equations to solve it. If it's got three variables, you'd need three equations to solve it. If it's got one variable, you only need one equation to solve it. All right, so I got two variables. If I can write two equations, then I can solve it. I'm going to pause for a second to see where I am time-wise. Okay, then I am going to leave us right here and pick it up lesson-wise. There's homework that you can do now, but I'm not going to try to explain how to finish this right now because we don't have time. But I'm going to draw that up on the board, and we're going to do this the same exact thing tomorrow with my two triangles, this being 30, this being 60, this being 2, and this being Y and H. And I'll show you how you could set up two equations with two variables to be able to solve for that. That's a typical thing you'd have to know on the test. So we'll pick that up again tomorrow there. Right now, I'm going to pause while I find the homework area. So on this page where it says assignment day 1, I need to just do a few practice from here. We're going to do this one right here, the very first one. Notice it gets a little icky on like problem 1 and then immediately is followed up by problem 5. Yes. I want you to also do problem 5, which is this one. Nope, those numbers are screwed up. I apologize. We are crossing off number 5. At least I realized it early. Let's just do problem 1 off of this page. Moving on to the next page. Come on, computer. All right, move on to this page. I'm also going to ask you to do this problem. You see how selective I'm being about which problems I'm asking you to do? That means I expect you to actually have these done tomorrow. There's also a key. If you look in Schoology, there's a key. Don't tell me if you have a key. Somebody explained how to do them. You should be able to put that all together and do these problems. All right, I'm going to move on to this one. It's very similar to the one we did as a practice one in class, so hopefully you caught that, and it'll be very similar. And one more, it's this one, where, again, I've given you more information. This is not as hard as the string problem. Try that one. There, that's a pretty small assignment. You should be able to have that done tomorrow, so that when we grade it in class and put it in the grade book, no reason why you couldn't have a strong score on that. All right, that's all I got for you for today.